All right, we're going to go ahead and get started. Good morning, good day, good evening. I am delighted to welcome everyone to today's webinar. My name is Veronica Cedillos, and I have the honor to serve as president of GeoHazards International. We have quite the audience today. We have about 20 countries represented based on registration, and we have a very diverse audience, people who are interested in more of the technical design engineering aspects of the earthquake desk. We also have local stakeholders who are interested in the implementation or relevance of earthquake desks in their own communities and schools. And we have also supporters of GHI, more generally speaking, and also those who have supported this particular initiative. So welcome all. I think there's going to be lots of great material, all kind of along these topics. So a quick note about Q&A before we jump in. Please use the Q&A button at the bottom of the Zoom window rather than the chat. If you could please put your questions there. We're going to be answering some questions in written form throughout the webinar, and then we'll also have a Q&A session at the end where we will answer questions live. But I encourage everyone to put in their questions as they come to mind. So for those of you that are not familiar with GHI, I just wanted to give a brief overview. GeoHazards International, we're a global nonprofit. We were founded in 1991 with headquarters in California. And our mission is to save lives by empowering at-risk communities worldwide to build resilience ahead of disasters and climate impacts. We work on earthquakes, landslides, tsunamis, as well as climate-related hazards. We have experience in over 30 countries. And particular to Nepal, we started working there in 1995. Before we jump into the particular topic of earthquake deaths, I wanted to give you a broader context of the multifaceted approach that we are taking to earthquake safety in Western Nepal. GHI works to promote safer new school construction and also identify and strengthen existing vulnerable school buildings. These are, very traditional ways of addressing earthquake safety that we know work. But unfortunately, given the vast number of schools to be addressed and the pace at which they're being addressed currently, if we only address school safety from these two perspectives, it would take close to 200 years for all of the vulnerable school buildings to be made safer. And for this reason, it is really important for us to look at interim solutions to help protect the lives of generation of school children in that meantime in vulnerable schools. So this is why we're looking at earthquake deaths. So as we jump in, I just wanted to give you a brief overview of what you're going to be hearing today. We're going to start with some background on the project itself. Then we're going to get into the design and technical aspects of the earthquake desk. We will then move on to the on-the-ground considerations in Nepal, and then finally end with local engagement and implementation. So to start, we're going to have the first speaker, Ms. Heidi Stenner, who's a GHI project manager. She's going to be talking to us about project motivation. Heidi has been the one leading this overall initiative. Heidi, please go ahead.
Thank you very much, Veronica. Appreciate it. And welcome to everyone. We're so glad you're here. So we're all here, this team, with one main goal, and that goal is to increase the safety of kids during earthquakes while they're at school. And specifically this project, our aim is to equip the local leaders in Nepal and schools and manufacturers with the ability to produce and procure quality earthquake desks independently so that they can place earthquake desks with the local schools to protect their children. So you might be asking yourself, what is an earthquake desk? So you'll hear a lot more about that next from Ido Bruno, but this is an amazing design by Arthur Bruder and Ido Bruno, and it's entirely designed to protect children from falling debris during earthquakes. So you might be wondering also why we are focusing on Nepal. Well, so there's the very high Himalaya mountains in Nepal and across the whole Himalayan region. That it's because of very active geology. And when you have very active geology, not only do you get the big hills that are mountains everywhere or elsewhere and the high mountains, but you also get a lot of earthquakes. And so the map on the right, these bubbles are showing different historical large earthquakes over the past. And the darker the circle, the more recent the earthquake, and the lighter the circle, the farther back. And also the size is roughly equivalent to the size of the earthquake. So you might remember, so in the middle is Nepal, And you might remember in 2015, there was the magnitude 7.8 Gorka earthquake that was very devastating. And a lot of schools were damaged. You'll hear a lot more about that from Mr. Surya Shrestha from NSET, Nepal. And another thing you might notice is that here in the far west Nepal, you see these very faint red circles, and that's because the last big, large earthquake was over 500 years ago. And so that's why we're focusing here in far western Nepal, because that area is particularly at risk. We know eventually there will be a large earthquake. And in addition, there's a lot of smaller earthquakes that are occurring. And so the far west of Nepal is our first focus area, but ultimately we would love to have earthquake desks in all vulnerable classrooms. Another reason why we're focused on the far west is because communities can be easily isolated by landslides during earthquakes or even monsoons. And also that there's just a lot of vulnerable schools. There also hasn't been any major rebuilding efforts like there has been in central Nepal after the 2015 earthquake. A lot of schools were rebuilt or retrofit in order to make them safer. So of course, buildings in earthquakes can be unsafe. And so you just see here some pictures. If you imagine sending your kids to school, you'd be hesitant because this can be scary. And these pictures on the left are from the magnitude 7.8 Gorka earthquake in 2015, but even more modest earthquakes. So a magnitude 5.7 or 6.4, depending on who you ask. The right two pictures are from the Jajarkot earthquake 2 years ago in western Nepal, far western Nepal. And you can see that this school building has had a lot of damage and it would not have been safe to be in it during the earthquake. And here on the right is my colleague Ishi Lote, and he is standing on another collapsed classroom. And this wood piece is an actual desk where students would have been sitting. Fortunately, in both of these earthquakes, class was not in session. So obviously we want our students to be safe during earthquakes. And that is why, as Veronica mentioned, GHI is working to really promote safer new schools and also with training for masons and things. And we're also promoting retrofit, but also earthquake desks we think can fit into that picture. So here's the situation as of 2021. There are approximately 35,000 schools across Nepal, and each school has multiple buildings. And if about 65% of them are seismically vulnerable, then how long might it take to make those all safer? Well, in the 7 years of Nepal's school sector development plan, 120 schools were retrofit or replaced each year. So if we use that rate, which takes a good amount of resources, it would still take about 200 years to get all of the schools to be made safer. So for the generations of kids that are going to school in the meantime, we think that earthquake desks could be an interim solution to help make them safer. So, okay, now that we have this beautiful design that is incredibly exciting, we wanted to know, is this even a feasible project for Nepal? So back in 2020 to 2021, we conducted a feasibility study and we visited 62 schools across 6 of the 7 provinces of Nepal. And we were looking at classroom size, classroom shape, the desk types, organization. We talked with people about earthquake desks. We looked at school vulnerability. We looked at how much the desks that exist cost, and we were exploring local manufacturing. So our main findings from that 2021 study are that classrooms can be overcrowded. It's not in alignment with the government's policy, but they can be overcrowded. And the desks typically are narrow desks that often seat 3 or 4 or more children. We also found that obviously small children use smaller desks. And we found that the stakeholders and people we talked with generally had a lot of interest in this design. We also saw that a large percentage of the school buildings are vulnerable in the far west. For example, a couple of different studies showed that in this one municipality in the far west, Amargati, that approximately 89% of school buildings are vulnerable to heavy damage or collapse in earthquakes. And that is not an uncommon finding across far western Nepal. So there's a lot of vulnerability. We also found that making prototypes, so these are just one-off, cost less than twice that of the regular desk amount, and that they last longer. So we also were thinking that because there's a lot of rural areas, transportation costs can be quite high for bulky desks. So ideally, desks should be manufactured as locally as possible. So some of our key conclusions from that 2021 study were that earthquake desks shouldn't be too narrow. We don't want them to tip over. We want them to have enough space to cover children. We need to prioritize putting earthquake desks into classrooms that do have enough space for the given number of students. And we need to finalize, so Ido and Arthur had designed a elementary school, primary school size desk, but it hadn't yet been fully fleshed out and built and tested. So we wanted to do that, which has been done. And we thought that earthquake desks had the capacity to be feasible cost-wise. So that was really exciting for us. So once the feasibility study was done, we felt like we could proceed. So over the 5-year program so far, we've made a lot of progress, and you're going to hear about that today from a bunch of different speakers. So I just want to mention, we went from building prototypes, training the manufacturers, to testing them. So it's very exciting, and I'm going to turn it back over to Veronica now.
Thank you so much, Heidi, for that. We're not going to move over to the design and technical aspects of the earthquake desk, and we're going to have 3 speakers in this category. So we have 3 speakers. We have Ido Bruno, Ben Shao, and Mark Beletzos. So to start, we're going to hear from Professor Ido Bruno, who's at the Bezalel Academy of Arts and Design, and he is one of the designers of the earthquake desk. So with that, please, Ido, if you can please go ahead.
Everyone, good morning. It's really nice to see so many of our friends and partners from Bhutan and from Nepal with us this morning or this evening, depending where you're situated. I'll just share my presentation. Go. And yeah. Okay, 1 second. Yeah. So I think we'll forward. Before we reach Nepal, I'd like to give a bit of a background to the invention and development of the earthquake desk. Our story begins in 2010 with the big earthquake in Haiti. My student at that time, Arthur Bruter, was exposed to images of collapsed building and with children under the desks in the school in Port-au-Prince. Arthur realized that the famous duck cover and hold protocol, which is the worldwide protocol for school children response to earthquakes in seismic hazardous zones, would benefit from a desk strong enough to create significant protection. This was and still is the case in many parts of the world, as you can see here and here. In these examples of the collapsed schools, one can see that when the school buildings are not built to withstand the earthquakes, the problem becomes acute. So Arthur began building prototypes and convincing people to test them. Those initial prototypes were far from a working product, but the preliminary tests gave us enough information to believe that we could reach a real solution. After further development, we filed for a patent, and then after Arthur graduated, we traveled the long and winding road that leads from an idea to a real-world working product. It took us 2 years of experimentation to reach results that were good enough to seek an official endorsement of our claims. We took 24 desks to Padova University in Italy, to the department that specializes in earthquake-related engineering, where we conducted a series of tests. Here's a view of some of these tests from 2012. On the left-hand side, you can see a standard Italian school desk. And on the right, various weights and crush scenarios being tested. So here's an 800 kilo weight and the dispersed mass. And then you can see a 1 ton weight compact mass. So we were extremely satisfied with the results. The desk proved to be able to maintain a significant safety zone underneath. This was achieved by mechanisms similar to modern automotive design. In order to do this, parts of the desk are designed to crumple and bend, and that way dispersing the energy and transferring it to the ground. This happens while a predetermined safety zone remains intact and protects those taking cover underneath. The desk also needs to allow for normal daily classroom activity. Our main challenge was to make it strong enough yet keep it as light as possible so that 2 children could lift it up and move it around if needed. The desk therefore weighs only 26 kilograms. Thinking of the cleaning requirements of the classroom, we lifted the lower cross beams to allow for a broom to sweep underneath. This diagram shows the various features that contribute to the safety performance of the desk. The top frame and diagonals, here in yellow, support the desktop as it folds or breaks, building a 2-stage resistance upon impact, effectively preventing the breaching of the safety zone underneath. The center beam in green, supported by 2 extra legs, not only keeps the structure from collapsing in the center, but also contracts to absorb some of the energy. And the corner fuses in pink pop into the legs when impacted, creating internal friction and allowing the desktop to fold and create diagonal slopes that deflect secondary debris. And the rubber feet create ground friction that subdues the horizontal movement of the desk. All along, we asked ourselves the simple question, can design save lives? We definitely believe it can, but in order to do that, we knew we needed to keep working, to find a way to get the desks to the places where they are most needed. And always with the best of partners. We knew it would have to be a team effort. So in 2015, we were invited to present the desk at the 3rd United Nations World Conference on Disaster Risk Reduction in Sendai in Japan. Several thousand participants came to discuss ways to build the resilience of nations and communities to disasters. Destiny made our paths cross with the GHI leadership. We were lucky to meet Karma Charing, Hari Kumar, and Brian Tucker, the then president of GHI. And on the carpet, literally on the carpet of the convention hall, a long and fruitful partnership was born. We were told that they just finished a campaign to convince children, teachers, and stakeholders in Bhutan to duck, cover, and hold. But they were worried that the desks were not strong enough. The earthquake desk seems to offer a solution. We created a system of training for local manufacturers in Bhutan, designed and built a set of plywood welding jigs, and a series of manuals that allow 3 manufacturers to produce good quality earthquake desks for the Bhutan schools. With joint effort of the Bhutan GHI team and the Ministry of Education engineers, we created a quality assessment and control method that worked for both the local manufacturers and the government agencies. And after a long and demanding process, we had the satisfaction of delivering a few hundred desks to local schools. We actually hope to be able to produce more desks in Bhutan quite soon. Now, in this video, I'll show in a second, you can see an earthquake drill with the earthquake desks in place in a Bhutan school. The Bhutan project helped us reach a number of goals. To design welding jigs and production manuals, to establish and support the manufacturer's ability to produce safe desks, and to create a quality control and assessment system that is acceptable by all stakeholders. We also were able to transfer the knowledge needed in order to manufacture and distribute desks independently, something we would like to scale up and move forward in Bhutan in the near future. And so moving on to Nepal, in 2020, we began a new and much larger project in Nepal. Nepal's population is 37 times larger than Bhutan, so it's a much larger and more complex project. Drawing on what we learned in Bhutan, we began looking at the complex challenge facing us in Nepal. Now, in the next few minutes, I'd like to quickly run through what we've achieved so far in Nepal from a design point of view, and what more and exciting goals and challenges face us in the near future. The transformation of jigs from plywood to steel allowed for enhanced precision and durability. Once we built the steel jigs with the first manufacturer, SRS, in Kathmandu, they served for training 2 new manufacturers in Western Nepal. So we now have 3 fully trained manufacturers that have the know-how to build 2 different models of the earthquake desk. The bespoke digital simulation tool created by the Arup engineering team gave us enhanced ability to push the development of the desk forward. Ben Shaw from Arup, who's with us today, will be presenting the simulator in detail, I think, soon, and elaborate on this wonderful tool. But I'd like to say a few words from the desk design perspective. In less than 2 years, the creation of the simulation tool has allowed us to add an elementary school model to complete the protective scope. We can now provide a full range of protection for school children of all ages. It also enabled us to design, build, and test side protection panels to address debris falling in diagonal directions, such as walls buckling due to specific school building features in Western Nepal. I believe Mark Villetz's presentation will relate to that when he discusses the various tests we conducted at Tribhuvan University. We also benefited from the simulation of a narrower desk design. Some of the ability to introduce desks to school is challenged by small and congested classrooms. With the simulator, we could digitally test design adaptations that might help us in the future to fit more desks into each classroom. So what would we like to do when we have the time and budget? Now looking to the future. I think we would like very much to expand manufacturer training. This will allow for better geographical distribution of manufacturing facilities and scaling up of production and desk placement in schools. We've learned that initial tool acquisition leading to quicker and more precise manufacturing is sometimes hindered by economic barriers and lack of adequate tools. We seek to create a program that will allow manufacturers to work with better tools earlier in the production process. We found that presentations and live demonstrations of the desks are highly effective. It's important for us to have a continuous dialogue with many relevant stakeholders, including the engagement of the public in crush test demonstrations. We'd like to do more of those. And in the longer term, in a future phase of the project, build narrower desk prototypes and test them physically. We believe that an earthquake desk classroom holds a number of advantages in disaster circumstances, a classroom rather than a single desk, but it is difficult to project the actual performance of many desks together. This requires sophisticated programming and computer power we hope we can tackle. And of course, our ultimate goal, to begin volume production and distribution of desks to as many schools as possible. At the end of the day, we want to have desks in place anywhere they can be effective. That's it for now. Thank you so much. And I'll say that it's an honor to be part of this project. Thank you very much.
Wonderful. Thank you so much, Ido. It's an honor to have you. We're now going to move to our next speaker, Dr. Ben Shao, who's a senior engineer at Arup, and he's been leading a team on the modeling and analysis of the earthquake desk. Ben, please go ahead.
Thanks, Veronica. Let me share my screen. Just 1 second. Looks okay. Let me know if you guys can see my screen.
Looks great.
Great. Yeah, thanks everyone for joining. So I will briefly share some Arup's contribution, which is mostly focusing on using simulation to support the engineering assessment of the earthquake desk. So before I start, I want to briefly talk about what is simulation, right? So simulation in a broader sense represents models or representations of real world process or system. They can help us to understand things quickly, and they can help us help to provide a lot of good insights without real world testing every single time. So in engineering space, we use simulation a lot to look at the performance of, say, buildings, infrastructure, and products under different types of loading. And it really helps us to gain a lot of insights from those simulation model. And you can see here, these are some examples of civil engineering application. For example, we could simulate how a building gonna should collapse under extreme loading, and how a connection can perform, how the vehicle can perform during the impact and stuff like that. So why we're thinking simulation can be important and add value to the project. As Ido mentioned about the desk design and also some of the testing. So looking at the desk itself, the engineering assessment of the desk is a very important part of this whole initiative to make sure that we understand how the desk is going to behave during loading, and then whether the desk is strong enough to resist the expected loading in earthquakes. And obviously, to do the engineering assessment, one best way to do is to do the testing, as you can see here. And Ido mentioned a bit, and I'm sure that Mark going to talk more about that in a minute. But why we need simulation? Because sometimes testing has limitations, right? You need to set up the test, it's lengthy, and sometimes it costs a lot. So it's not that flexible. And so simulation can really help to supplement the test when you're doing the design and the evaluation of this earthquake desk. So that's where Arif's contribution comes in, where we do simulation. So our main objective is firstly to explore whether we can do simulation to simulate the desk behavior, because it's a quite complex behavior if you're considering different parts of the desk that interact with each other. And then if that is successful, we can use the simulation as a tool to quickly test out, for example, the design iterations, as Ido mentioned, and also looking at different things. Like, for example, if you have uncertainty in the material or on the connection design, how this behaves. And those things, you can always do testing, but you can't do like hundreds or tons of testing, but we can do simulation to quickly assess the performance and get some quick insights. So we partner with JHI and Ido and other desk designer to firstly develop the simulation model in a computer software called LSDyno, which is a multi-physics simulation software we typically use. So we take the geometry of the desk and the material property of different parts of the desk and the detailed design of the connection, and to best modeled in a finite element model in a computer software. And then we validate the model against different type of testing. So we're looking at the testing from different loading scenario and different locations of loading, different amplitude of loading, and to confirm that the simulation model can capture the behavior well. So here are some pictures that you can see from the testing itself versus the simulation. You can see the simulation model cannot only just simulate the global behavior of the desk, but also can capture the local failure or deformation pattern of the desk really well. So these are comparison from different testing scenarios, not just one single validation for one single task. So after we confirm that the simulation model can really produce good insights by reproducing the correct behavior of the desk, both locally and globally and locally, then we use the simulation to support the evaluation, engineering evaluation of the desk in various aspects. For example, we use the simulation model to test out how the desk is going to perform if you have different size of the desk and different design aspect. And also we can use in the simulation model to explore, for example, what is the ultimate load of the desk. And some other things we're looking at is that, for example, if certain part of the desk manufacture process has uncertainty, for example, the welding has a low quality, how that's going to impact the desk behavior. So the simulation really adds a lot of values to the project in terms of engineering assessment, and it really provides a useful tool to quickly assess the behavior in a very efficient way. So we're very proud to be part of the team and develop the simulation model to support the desk design and evaluation. And we will continue to support this initiative using our expertise in simulation and the risk assessment. So before I hand back to Veronica, I want to acknowledge the entire Arif's team, and also to acknowledge Arif's Global Community Engagement Fund to support this work. And that's all I have. Thanks, everyone. I will hand back to Veronica.
Thank you so much, Ben. I find that simulation work just fascinating. We're now going to move to Professor Mark Valetzos at Merrimack College, who led the physical laboratory testing efforts. Professor Valetzos, please go ahead.
Hi, everyone. My name is Mark Valetzos. I'm a professor of civil engineering at Merrimack College. I'm going to talk to you about the physical testing results. So the goal of physical testing in Nepal was to better understand how Nepal-built earthquake desks are likely to behave in vulnerable school buildings during strong shaking, and to understand the extent of their protective abilities for school children. In terms of physical testing, we did two types of testing. We did compression testing, shown here on the left, where we put desks under a testing machine and just push down on top of the desks. And we also did dynamic testing here with a shock table at Tribhuvan University. We studied three different loading scenarios on the compression test, shown here. We did a 2-point concentric loading, we did a 2-point eccentric loading, and then we did a uniform loading where we put bars on top of the desk to study how different loading scenarios might impact the way the desks perform. So the damage characteristics are shown underneath. So we assessed these with load displacement curves shown here. I won't get into the details, but overall, all the different loading scenarios supported significant loading. 98 kilonewtons was the minimum loading we saw, shown here with the 2-point concentric. So that's the weight of about five cars, so pretty significant loading. And they all maintain their safety zone underneath. They all can absorb significant energy, just like a crumple zone in a vehicle. So it absorbs damage and still keeps a safe zone for people. In terms of the shock table testing, the dynamic loading here, we designed a full-scale mock-up of a school building. This had typical stone masonry wall thicknesses with mud mortar. We had a heavy roof system with bamboo planks and mud filling, as well as slate stone roofing. We had a roof wall connection to ensure that the roof and wall stayed connected so that the whole system collapsed in one go. The intent of this was to design the largest reasonable loading on the desk, not necessarily the most common school system out there, but the largest reasonable loading that a desk might feel. So this is a system with heavy fragile walls as well as a heavy roof. In terms of the shock loading, we applied several small shocks by pulling back the pendulum a small amount up to 10 degrees. And this produced fairly small shocks, which produced minor or moderate damage in the building, nothing on the desks. And then we produced a single large shock, which caused full collapse of the building, which would be the largest loading on the desks. Okay. Notice in here you see where the desks are laid out. You also see some water jugs underneath, which simulated children. Here's another view showing out all the layout of the desks. I will point out the dark blue lines here represent some desks had side protection. The orange is where we put benches to study the flow. Okay, let's look at some quick videos. That was the largest pendulum loading, happens very quick. Let's look at that in slow motion. Let's start that over. Here's the impact. Pendulum impacts, boom. You see the desks topple a little bit. Look at the wall collapsing here, boom. You get some wall debris. Notice it's not all the wall at one time, but it's a decent portion. It's really only half the wall width collapsing. The stones are separating, so you're getting really repeated impacts. And as this debris collapses, so as the roof collapses, it hits the debris and pushes the desk sideways. You get that lateral loading, and the roof completely splits. Let's look at another view. Again, full speed first. Okay, let's do that in slow motion. You see the wall splits. You see some damage, that vertical crack up the wall, separating the wall widths. Wall is starting to collapse here. See the individual stones are falling. Right here, you see a portion of the wall impact the top, about to impact the top of the desk. But again, it's only a portion of the wall widths. Largest load, boom, happens there when the roof hits the top of the desk. Okay, in terms of debris flow, looking at desks with no side protection here, you see a large amount of debris entered the safety zone in all of these. You also see that the jugs have toppled over, which suggested they were impacted by the debris. We did not see any puncturing of the jugs, so perhaps that means non-lethal damage to non-lethal injuries to the children. With side protection, however, the side protection significantly limited the debris into the safety zone. All the jugs remained upright, and there was no puncturing of the water jugs. In terms of the benches, it perhaps limited some of the debris flow, but there was still significant debris that rolled under and into the desks. You did see some permanent damage to the benches, which suggests what might happen to traditional Nepal-built desks as opposed to earthquake desks. Notice in here that there's really only minor cosmetic damage to the desks. Primary findings, the earthquake desks are all very strong. They can absorb significant energy, so similar to a crumple zone of vehicles. The earthquake desks easily withstood the collapse of a single-story mock-up school building. The only cosmetic damage to the desks. The safety zone was well maintained. So that suggests that these desks could withstand an even larger collapse loading than what we showed here, which again was considered to be the largest reasonable loading for a single story. The side protection significantly reduced debris into the safety zone and improved the safety of the children, so I would recommend moving forward with those. The lateral wall debris wave did push the desks sideways, but they did not topple. Overall, we'd say the earthquake desks are appropriate for all single-story building types in Nepal and potentially appropriate for two-story buildings. Thank you very much.
Thank you to Professor Veletzos, and thank you to all three speakers in this category. We're now going to move on to the next section, covering on-the-ground considerations. And we're going to have, similar to the last section, we're going to have three speakers, Dr. Sweta Sijapati, Professor Gokarna Bahadur Motra, and Mr. Surya Narayan Shrestha. We're going to start with Dr. Sweta Sijapati, who's GHI National Coordinator for Nepal, and who's been leading our on-the-ground efforts. Sweta, please go ahead.
Yeah, thank you so much, Veronica. So you all have heard about the design and technical aspect, but I'm going to talk more about the manufacturing aspect of the earthquake desk. And for this process, during this process, we evaluated many manufacturers in 9 districts across Nepal. And the one thing that we wanted to convey to manufacturers was the earthquake desk is not an ordinary classroom furniture, but it has a life-saving function, and it must withstand heavy falling debris during an earthquake. So any weaknesses in the material or joints could cause damage to the decks and even put the lives of children in danger. So the precise workmanship and the quality of the material were very critical and non-negotiable aspect of the decks, so to ensure that the decks can perform as per designed. The manufacturers also needed a special training on the manufacturing this decks, so that so that we can ensure the quality and the quality of the workmanship as well as the materials are as per standard, and also the decks built are consistent throughout, irrespective of where it is being manufactured, and are reliable enough to be placed into a vulnerable school buildings. And as Heidi has already mentioned, that our focus is more on far western region where the need of these interim solutions are high. We're also more focused on local manufacturing of the decks so that we can build community capacity and also strengthen community confidence in earthquake safety solutions, as the community and the school authorities can see these decks being built in their community using the local materials rather than it being outsourced. And the other aspect would be to reduce the cost, transport cost to the remote and rural areas of Nepal. Considering all these factors, we now have 3 manufacturers trained, one in Daradhura, one in Kailali, and one in Bhaktapur, which you can see in the map of Nepal. And here are the photos of the manufacturer being trained by our team. We also did a cost comparison study of the earthquake desk with the normal school decks that is being used here in Nepal. And we found that most commonly used decks were 4 seats with bench attached, and that it would cost about $85 to $145. That would be approximately 11,000 to less than 20,000 Nepalese rupees. Whereas the other regular decks, like 2 to 3 seats, would cost about 45 to 65, and the earthquake decks would cost 2 seats prototype would cost about $70 to $110. At first glance, you'll see that the earthquake desk seems a bit expensive as compared to other, but here I wanted to mention that these were the prototype decks built, which was in very less number. And also the materials and the precise workmanship that goes into making this earthquake desk are of very high quality, which adds up to the cost of the decks itself. But when we when we think about it in a long term, we see that the earthquake desk can be made cost effective because it requires very little maintenance as compared to the regular decks. And this is from our experience of placing earthquake desks in Bhutan for almost about 10 years now. And we are also exploring opportunities for the cost reductions. And we found that once we go into a volume production of the decks, the cost can be minimized. The other factor would be to train the local manufacturer and produce the decks locally so that we can minimize the transport cost, which significantly adds up here in Nepal when we have to transfer the decks to much hilly, remote areas, and also to replace some of the components of the decks. But here I would like to emphasize that when we say like changing the components of the cost, I mean we are not by compromising the quality, the strength, and functionality of the decks, and this can be only done after the series of test and simulation. So you can see we have in future we are planning to find more other ways to kind of reduce the cost. And with this, I would end my presentation and hand it over to Veronica. Thank you.
Thank you very much, Sweta. We're now going to move over to Professor Motra at Tribhuvan University at the Institute of Engineering, who has provided technical support, particularly as we look to implementing quality control and quality assurance processes. Professor Motra, please go ahead.
Okay. Good morning, good evening, everyone. So my part is on the quality control aspect. So we all know that these school tables, these earthquake table decks are very useful for the vulnerable schools, which we can see in this slide. One of the schools that was damaged during 2015 Gorkha earthquake. So for the fulfillment of the set objectives, the quality control aspect plays a very vital role. So for the proper quality control, first of all, we should have raw materials, proper quality raw materials. That means whatever we are using, those metal parts, and then wooden board, those are of proper quality. since these materials are manufactured in the factory with good process and good quality control, we can rely to some extent on the quality provided by those manufacturers, but for certainty we must test at site. Hiring third party quality control is also required, and then proper equipments for the manufacturing of those tables is also necessary. So we should assist to acquire those required equipments also. And after that, skilled manpower is very important. Train and skilled manpower for the manufacturing process, especially for those metal parts cutting and then welding. Welding is a very special uh, type of thing, and it requires special quality. So for the proper functioning of these tables, welding plays a very vital role. So we have to ascertain the quality of those things also. And finally, we must have inspection during during those process to control proper quality. So different material parts including metal frame, welding rod, corner fuses on the tables are also very important. Rubber shoe, wooden board. We will ascertain the quality through testing, field testing and verification. Similarly, human resource, trained welders and carpenters are also required. And for those things we have to have proper material standards and proper specifications, and we should have proper standard for trained and skilled manpower to be used, as well as for the equipments to be used also. For that, we will have quality assurance checklist. We will prepare quality assurance checklist of all those materials, manpowers, and for the product also. In the process of manufacturing, we must have regular as well as interim quality control process. For that, we will prepare quality control checklist, and accordingly regular checking during the process will be there through the site supervisors, and in between we will have through quality checking from the experts also. So and then material storage and other processes should be verified, and test certificates of all the materials as well as manpower is required. Finally, during the manufacturing process, we should have proper safety for the work persons. So that should be ascertained in the site itself. And welding quality, as I already told, is very important, and skilled manpower are required, as well as quality of welding rod is very important to have proper quality tables. So inspection and testing is must during the manufacturing process. That will be provided through regular and periodic testing. Thank you very much.
Thank you so much, Professor Motra. We're not going to move on to our last speaker of this section on the ground consideration, Mr. Surya Narayan Shrestha, who's Executive Director at the National Society for Earthquake Technology, Nepal, NSET. NSET has been a key local partner throughout this multi-year effort, and Mr. Shrestha is going to speak to us about the relevance of earthquake deaths in Nepal.
Thank you very much, Veronica. Good morning, good afternoon, good evening to everyone. I'm going to talk about how and why these earthquake disks are relevant to Nepal. As Heidi already mentioned about the earthquake hazard of Nepal, equally the vulnerability of school buildings is very important. We observed during 2015 Gorkha earthquake in Nepal affected more than 9,000 schools throughout the country, and which is due to the poor construction materials and poor construction supervision, non-compliance to building codes during the design and construction. All these contributed to the severe damage of the school buildings during the earthquake. And still, we can see most school buildings in rural areas in Nepal are unreinforced masonry buildings, which are relatively highly vulnerable to earthquake ground shaking. We have observed this kind of damage during the 2015 earthquake and during the recent 2023 Jajarkot earthquake also. Partial damage of the school buildings, of masonry buildings, a roof collapse of the masonry buildings, as well as damage to concrete buildings also. So we have observed not just full collapse of the buildings, school buildings during earthquakes, but the school buildings might suffer partial damage, damage grade 1, 2, 3 to significant damage or full collapse of the school buildings. We need to consider different levels of damages, potential damages to the school buildings when we consider the safety of the school children or resident of the buildings. The 2015 earthquake and 2023 earthquake in Jajarkot both happened during non-school day and non-school hours. Fortunately, because of that, the school casualty was significantly less during both of these earthquakes. But if the earthquake had occurred during school day and school hours, the casualty could have been significantly higher. This suggests the requirement of safety in our school system, school building systems. The best solution is definitely strengthening of all school buildings throughout the country. However, this takes probably several years. We have more than 30,000 schools throughout the country, of which we have more than 80,000 plus school buildings, school blocks, and of which more than 50% are highly vulnerable to earthquakes. If we consider the retrofitting progress so far, during past 20 years, we have retrofitted almost like 2,000 school buildings throughout the country, excluding the 5,000 plus school buildings. Those were reconstructed, safely reconstructed after the 2015 Gorkha earthquake. So at this speed of retrofitting or strengthening of school buildings, it will take several years to fully construct or reconstruct or retrofit all these buildings to a required level of safety. And also this requires significant amount of resources for retrofitting or strengthening of these buildings, which is a relatively difficult job to accomplish. That is why having these earthquake desks in vulnerable schools is a good interim solutions to reduce the risks. Another consideration we have observed during the 2015 Gorkha earthquake, this is from a research done after the 2015 Gorkha earthquake, Marla Petal and team on which we are also part of the team. And one of the important observation was that the casualty, most of the casualty happened because of the trapping and crushing of the residents, and also because of the struck by the falling objects. This suggests that if we can protect our heads and other serious sensitive part of the body, then the persons can be saved. That is the important observation from the 2015 Gorkha earthquake also. Another consideration is we know that Nepal is highly vulnerable to earthquake. Nepal's seismic hazard is very high. But at the same time, we also know that there can be frequent low to moderate magnitude, moderate intensity earthquakes, causing minor to moderate structural damage and non-structural damages. So these minor to moderate non-structural and structural damages, because of these falling objects or the partial damage of the walls, can cause significant harm to the students. And by these earthquake desks, for these non-structural damages and for these falling objects of the structural elements, these earthquake desks can can prevent the casualties. Another consideration is in most cases, existing desks are very poor in normal circumstance in Nepal, which require significant and regular annual replacement, repair, and maintenance, which requires significant costs. And investment of such earthquake desks can be very cost effective in the long run. And definitely costs can be reduced by further improvement in the disk design and also by scale of manufacturing of the desks. And local adaptation of design, local manufacturing, and local involvement for understanding and dissemination of the desks will enhance the effectiveness of the desks so that the lives in schools can be protected. So even a single life protected in a school or in a building by use of such desks will be definitely a added value in this kind of highly vulnerable countries. So I stop here. Thank you very much, and back to Veronica.
Thank you so much, Surya. We're not going to move on to the last part of the content for the program, and that's on local engagement and implementation. And for this section, we have two speakers, and we're coming back to Dr. Sweta Sijapati. Sweta, if you could go ahead.
Yeah, thank you once again, Veronica. So after we did the laboratory test, we continued with a series of discussion with the national, provincial, and local government representative, especially of Sudur Paschim province, to know how these earthquake tests would fit into that area, and also to learn more about the government mandates for school safety. And during these discussions, the stakeholders and municipalities showed great interest in our work, which and also helped us to identify requirements and highlight gap that needed attention, especially talking about the school building typologies prevalent in that area, and also about the government plan for retrofitting, reconstructing school, along with the school mergers plan as well. So we also did 2 rounds of workshop with live demonstration, with an objective to share key findings and also to gather feedback from national and local stakeholders. The highlight of the workshop was to demonstrate the deck strength, safety performance, and function through live demonstration. And here are the pictures of those workshop. Now I will share a small video showing the live demonstration. The first live demonstration we did was for the Dhangadi workshop, and we did it in Ghanteshwar Secondary School in front of school children, school authorities, and mayors from various municipalities who attended the program. And here a load of 700 kg was dropped from a height of 3 meters, which is approximately the height of a single-story building. The second drop test we did was at Institute of Engineering, Pulchok, and we did that in front of the undergraduate and master students, and also there were presence of faculty from Department of Civil Engineering. And here a load of 710 kg was dropped from a height of 3 meters. We also did the same drop demonstration in a regular desk, and a weight of 350 kg was dropped from 3 meters. And as you can see from the results, the regular desk was completely damaged, whereas the safe space under the earthquake desk was still maintained, where children could take shelter during the shaking. The workshop with live demonstration generated a lot of enthusiasm and support from the participants. And we collected feedback, including positive aspects, challenges, and potential solutions. Here in the picture, you can see the participants explaining, gathering group work, and also giving us feedback in a written form. And apart from that, we also have several rounds of discussion with the school authorities, including principals, school management team, on the relevance and adoption of the text. And till now, we have got very positive response from them as well. And now we're more focused on multi-level government engagement, where we are discussing with the various government to know more about to get more data information so that we can use that for our future work when we are selecting schools for placing the text. I will share a small video with the stakeholder feedback collected.
आज जुन हामीले एउटा डेस्क त्यो डिजाइन अत्यन्त राम्रो बनेको छ र गोदावरी नगरपालिकाकै 1 नम्बर वडामा अवस्थित हाम्रो चाहिँ विद्यालयमा गएर अहिले हामीले त्यसलाई प्र्याक्टिकली हेर्दाखेरि 700 किलो वेट चाहिँ हामीले एकैचोटि त्यो डेस्कमाथि हाल्दाखेरि कम्युनिकेसन अप्ठ्यारो नभएको अवस्था देखिन्छ होइन। वास्तवमा यो डेस्कहरूको प्रयोग गर्दाखेरि चाहिँ त हाम्रो विद्यार्थी नानीहरू सुरक्षित रहन्छन् भन्ने कुरामा दुईमती छैन।
आजको जुन यो 700 किलो चाहिँ वेट धान्ने जुन डेस्कको चाहिँ प्रदर्शनी यहाँ भएको छ, यो डेस्क चाहिँ यदि विद्यालयमा पनि सर्वसुलभ तरिकाले चाहिँ कुनै डोनर अथवा कुनै यस्तो चाहिँ सहयोगी संस्थाले चाहिँ उपलब्ध गरायो भनेपछि विद्यार्थीहरू चाहिँ सुरक्षित रहन्छन् भन्ने चाहिँ मलाई लागेको छ।
हामीले 700 केजी वेट राखेर हामीले चाहिँ प्र्याक्टिकल गर्दा पनि त्यो डेस्कहरू सामान्य ड्यामेज बाहेक अरू केही पनि भएको देखिएन। भूकम्पीय रूपमा जोखिम संरचनाहरूमा स्कुल बिल्डिङहरूमा यो डेस्क राख्दा त्यहाँका विद्यार्थी भाइ बहिनीहरूको जीवन सुरक्षा हुन्छ भन्ने कुराहरू चाहिँ आजको प्र्याक्टिकलबाट प्रमाणित भएको छ।
इनकेस भूकम्प आइहाल्यो भने पनि स्टुडेन्टहरूले बाहिर भाग्दाखेरि भयो अनि क्लासमै पनि यताउता जाने बेला भयो धेरै जस्तो एक्सिडेन्टहरू हुनसक्छ। जो भूकम्प प्रतिरोधी डेस्कहरू छ 700 केजीको कङ्क्रिटको लोडहरू त्यसमा टेस्ट गर्ने बेला चाहिँ एकदमै नै यो सेफ छ। यो
आज लाइभ डेमोन्स्ट्रेसन हुँदाखेरि चाहिँ नेपालको कन्टेक्स्टमा ग्रामीण भेग र पहाडी ग्रामीण भेगहरू त्यस्तो ठाउँको लागि चाहिँ यो डेस्कहरू एकदमै समय सापेक्षित र सुहाउँदो खालको चाहिँ डेस्कहरू छ। 700 किलो लोडमा जो टेस्ट गरिएको छ त्यसमा चाहिँ खालि माथिपट्टिको प्लाइवुड मात्रै भाँचिएर नेपाल सरकारले चाहिँ यसलाई जति हुन्छ आफ्नो उसमा चाहिँ स्कुलहरूमा सरकारी स्कुलमा चाहिँ यो डेस्कहरूलाई चाहिँ सकेसम्म बढी प्रयोगमा ल्याइदियो भने पछाडि चाहिँ ज्यानको जोखिम चाहिँ त्यति नै कम हुने गर्छ।
यसलाई चाहिँ एउटा राष्ट्रिय रूपमा चाहिँ राष्ट्रिय कार्यशाला गोष्ठी गरेर यदि नीतिगत रूपमा नेपाल सरकारको नीतिगत रूपमा चाहिँ यो कार्यक्रमहरू अगाडि बढ्यो भने यो चाहिँ सुदूरपश्चिम फेरि यो भूकम्पविदहरूको भनाइअनुसार चाहिँ साह्रै जोखिमयुक्त ठाउँ भयो भने यो भूकम्पका कारणले हुने जोखिमहरूलाई चाहिँ धेरै न्यूनीकरण गर्न सकिन्थ्यो भन्ने मलाई लाग्छ।
यो कार्यक्रम अहिलेको अवस्थामा एकदमै आवश्यक र सान्दर्भिक कार्यक्रम हो र प्रदर्शनी पनि भयो माथि घण्टेश्वर माविमा। यसलाई लागू गर्नका लागि त्यस्तो खालका भूकम्प प्रतिरोधी भवन र ती डेस्कहरूको व्यवस्था गर्नको लागि स्थानीय तहसँग साधन स्रोतको आवश्यक छ। धेरै कुरा हामीले सिकेका छौँ र हामीले सिकेका कुराहरू हामीले उता पालिकामा गएर विद्यालयहरूमा गएर सबैलाई सिकाउनु पर्ने बताउनु पर्ने आवश्यकता छ।
After the workshop, we also did a wider sharing of the earthquake desk, and we participated in the 27th Earthquake Safety Day, where we explained the key features of the desk. And interestingly, the Prime Minister himself remarked that this is a very meaningful work for Nepal. And we are also expanding our outreach through conferences, webinars like this, through social medias and key programs. And we've been receiving positive feedbacks from several medias as well. And our future plan is to collaborate with government as well as other organizations who are working for the school safety. And with this, I would end my presentation and hand it over to Veronica. Thank you so much for listening.
Thank you very much, Sweta. And now we're to our last speaker, who's going to be talking about the current plans, and then back to Heidi Stenner. Thank you very much.
Thank you, Veronica. Yes, so what is coming up now? We have for the coming year some exciting work. We are going to finally be putting desks into classrooms. We think about 100 of them. So in order to do that, we'll be working with 2 or 3 local manufacturers to develop, fast and more cost-effective production of desks that meet quality standards to reduce the cost. We also want to support their purchase of key equipment to make them faster and cheaper. And we want to make sure that the parts are of consistent quality. We're hoping to train another manufacturer in the Far West as that's feasible. And again, we want to reduce costs through volume production and through design innovation. We also, once the desks are in schools, we will be doing training so that everyone knows the proper and safe use of the earthquake desk. And we will be conducting drills, the drop, cover, and hold on drills. And hopefully that will become an annual or more frequent occurrence with the schools, the drills. As Professor Motra was talking about, we need this quality assurance, quality control program, QA/QC process. And additionally, we want to test that and improve it because it's just beginning. So we need to make sure that the manufacturers are safe, have quality checklists, evaluate that the desks are actually meeting that quality standard. And then we need a certificate or some sort of proof or show or document that shows that these desks are the quality that they need to be so that purchasers can be assured. We're going to continue communicating and seeking feedback from stakeholders and collaborating with 1 or 2 pilot communities in placing our desks. And so we can learn from that process. And we're supporting efforts to kind of mainstream this process with the local stakeholders. So Arup will be providing further benefit on the program by including more simulations of design modifications and conducting sensitivity tests that will be very useful. They may be able to simulate multiple desks in a classroom. It starts to get a little more challenging and everything, but then, we may also be able to do 2-story simulation models or use different building typologies and simulate the effect of that failing onto a desk. And we want to make sure that our selection process is very clear regarding which schools will be receiving the desks as far as priority. So obviously we want as many kids as possible to get the desk, but with limited budget and time and volume of actual desks, we have to prioritize. And so we want to be very clear about that. It will incorporate government data. They have information on when a school will be abandoned or merged and the building vulnerability. We want to maximize benefit for the most students. We also want to be able to leverage new opportunities so we can get more desks into schools. And we want to be clear when we communicate these criteria with the stakeholders. So that's it for me. Thank you very much. We look forward to your questions.
Thank you very much, Heidi. And so that concludes all of our main content. I'm just going to take a couple slides to summarize and recap for everyone. So in summary, our progress so far for our program in Western Nepal, with about $300,000, we've been able to train 3 manufacturers to produce earthquake desk prototypes. And then we've conducted these rigorous laboratory tests on these prototypes. We held 2 drop demonstrations for stakeholders at workshops, and along with Arup, we developed a detailed virtual model of the earthquake desk. And upcoming efforts, with Heidi kind of just summing it up in terms of what's funded and ongoing, some of which mentioned by Heidi just now. We're looking to set up processes for volume production of earthquake desks, and this is going to be done alongside local manufacturers. And in parallel, starting to think about developing an initial strategy for the quality assurance and quality control processes, which are so important for the performance of the desk. And as part of these funded and ongoing efforts, we're very excited to be actually placing around 100 earthquake desks in vulnerable schools. So that's going to be happening in the next year or so. But in parallel to that, we're also seeking additional funds to help us move forward with other near-term needs. And this includes extending this initial quality assurance, quality control program. And then we also have a lot of ideas in ways to facilitate earthquake desk implementation. And so this could look like developing information and guidance materials for local leaders to understand how can earthquake desks be valuable, where could they be most useful. Similarly, developing materials and conducting campaigns for public awareness. And a really important aspect is the policy advocacy. And this is to help set up mechanisms to help make procuring of earthquake desks sustainable into the future. And of course, we always welcome more funding so that we can place additional earthquake desks in vulnerable schools as part of this initiative. Looking beyond the near term, we are interested in expanding our focus. Right now, we're very interested and focused in Western Nepal, but there's a lot of need across the country. And we've also been very focused on government schools, so we'd love to expand that to private schools. Similarly, we would love to push along the quality assurance, quality control program and get to a point where we can support a launch of a self-sustaining program. Because ultimately what we're after is we want this to be a Nepali earthquake desk so that this can be sustained and continue into the future after any one of our projects or initiative is over. And finally, we are very interested in coming back to Bhutan and reinvigorating the earthquake desk program there. You heard some of that program from Ido, but we've learned so much since then. There's been so much progress. We now kind of fully developed their elementary size school desk. We tested the side protection, which we saw was very valuable, particularly for stone masonry building. When you see we have this lateral falling debris that could provide enhanced protection. So we would love to bring in these lessons back into the program in Bhutan. So with that, I just want to offer that if anyone in the audience knows of foundation or organization who may be interested in supporting these additional initiatives and activities, please reach out. We would love your advice and suggestions. So with that, I want to give a huge thank you to our extraordinary line of speakers today for providing their thoughts, their insights, all their contributions of what made all this work possible. So a huge thank you to all of them. I'd like to also take a moment to express a heartfelt thank you to the funders who have made all this work possible. I particularly want to thank Verisk, who has provided multi-year funding. Without them, we could not have done any of this. Similarly to a private anonymous foundation that provided a lot of the seed funding that helped us figure out whether this was even feasible. Vanguard Charitable, who's provided more recent funding for the ongoing efforts, as well as Arab's Community Engagement Fund that made the technical modeling pro bono support possible, which has been incredibly valuable. And it's we already see that it's going to provide so much value moving forward. So before I end, I just wanted to note that you saw certain speakers today, but the group of people who have contributed to this effort and made this possible is really incredible. It's close to 50 people across 7 countries. And I find this incredibly inspiring and quite beautiful that so many people from different walks of life are coming together with the goal of protecting school children in vulnerable buildings. So with that, I'd like to thank everyone for joining us and move on to the live Q&A section. So we will try our best to get through as many as we can. I know we've answered some in written format, but let's see if we can answer some live. Let's see, give me a second. All right, so why don't we start with a question for Ben, and this is about the model. So in what specific ways does the simulation model make the assessment process more efficient compared to traditional methods?
Sure, yeah, thanks for the question. I think, I imagine the traditional method is meaning like testing, experiments work, right? So more efficient is basically, for example, if I gave an example during the presentation, if the desk, for example, the geometry changes, right? And then we want to test out whether the impact capacity is compromised or the desk behavior is different, then we can easily just do in a computer model and then changing the geometry, and doing that is probably a turnaround of like few hours, right? But then if you want to manufacture a desk that has a different geometry and then set it up in the lab, for a traditional kind of assessment, that will take much longer time and effort, right? And it's very important for this kind of things to work in the design stage. For example, if we want to iterate on the design, and it's very important to have a quick turnaround time to understand how the thing changes, and then you can keep optimized on the design. And at the same time, there are other things that we can easily test out. For example, you don't know the certain things. If you want to see if the weld quality is not good, or is there's material uncertainty, all this kind of stuff. So using a simulation model, you can easily get the answer in terms of hours comparing to, traditional tests. So that's kind of the efficiency that I want to address. Hopefully this answered the question. Yeah.
Thank you very much, Ben. Thank you. All right, so let's move on to the next question. I think this one will be for Ido. In the context of earthquake safety, what are the primary factors that determine whether furniture such as desks can effectively withstand the impact of heavy falling debris, and how do weaknesses in joints or material choices contribute to potential failures in such events?
Okay, so very briefly, we needed to consider I would say the two poles of this project. One, to create a very simple and cheap solution, something that countries can actually purchase for their schools using standard materials. But we needed them, of course, to perform well. So we worked during the development stage. We worked with industrial grade materials, which we knew are available worldwide, and eventually we used a number of standard steel profiles and a very standard industrial plywood. So these are the materials, and really the performance of the desk is in the way it's constructed, in the way it's designed and constructed. I hope this answers the question.
Thank you very much. So this next question, I can see various people answering it, so I encourage those people to chime in, but it's about regarding, it says, despite the availability of earthquake-resistant design, adoption often remains low. What role do government policies, public awareness, and community-level education play in ensuring that safer material and furnitures are actually used? Heidi, do you want to start with making a comment on that? And I think if we can hear from our Nepalese colleagues on that as well, that would be great.
Yeah, I was thinking actually that Surya Presta, you would be a fantastic person to answer. I'm happy to follow up after.
Great.
I will definitely. That is very important. I mean, that is the key. I mean, having just quality material or quality system is not enough. Adoption of that quality materials and quality systems is equally important. And for that adoption or use or implementation of that system, we have to work at multiple levels, starting from the community. Communities should accept it, and also local authorities need to accept it and implement it, and of course federal government or provincial government also need to accept it, and policy need to support it. That is why one of the key area of our work and yeah, it has been done that way also, that we work at multiple levels. For example, we saw in the videos that a mayor from municipality has completely understood the process, and that is similarly at the federal level also we have several workshops for discussion about this earthquake desk. So that's why it has to go hand in hand. The material or design or manufacture only is not enough. We have to work hand in hand for having it replicated in many schools.
Great. Thank you very much for that. Anybody else want to add something to that?
I guess I would just say that policy can take some time, but of course it's critical, and that we think that the earthquake desks are one thing that is a little more speedy answer, a solution that can be implemented in more speedy timeframes. And so policy would still benefit, well, policy is required to benefit everyone as far as safety, but earthquake desks, if they could also be implemented into a policy level, that could be useful too. We've got so many questions. I'll keep my talk short.
Thank you. Thank you very much. So the next question is for Professor Motra. And the question is, what standards are used to select the materials for the desk?
Thank you. In the local market, mild steel is easily available all over the Nepal. But quality of those materials should be ascertained through test certificates, through the certificates provided by the manufacturers, as well as through random sample selection and testing also. We have to verify the quality, whatever mentioned in the certificate. That is very important. Since steel is manufactured in the industry, quality control process is very easy. If the supplier intends to provide quality material, we can trust on the supplier certificate also, but we have to verify it. And the plyboard is also manufactured in the factory, so quality control process is easier. We have to have some proper test to ascertain the quality. Thank you.
Thank you very much. So the next question is, I will first send it over to Sweta, but maybe invite others to comment. The question is, what are the financial and logistical challenges in introducing earthquake tests on a large scale?
Thank you, Veronica. Yeah, that's a very good questions. And we are also kind of exploring a lot on that aspect. And we've been trying to have several round of discussion with the municipalities also to identify like potential manufacturers in the area. We don't want, like I already mentioned in my presentation also, if we can reduce the transportation cost only in that would reduce a lot of cost itself. So on financial aspect, we are still exploring a different mechanism where we can reduce the cost. And like you mentioned, some of the areas in Nepal, the very remote areas are very difficult to reach, especially through the transportation. So if the manufacturers are available and if we can provide trainings to them, we would reduce the travel time and also the cost itself, so that the school doesn't need to come to a more urban cities area to just for the delivery of the decks, and that would also be our priority. But this is an ongoing process, and we're still in a very early stage to say exactly how we're going to manage. But we are having a different level conversation with the local government, even the school authorities, to see that this logistic and financial challenges would be reduced. Thank you, Park. I hope I answered that.
Thank you very much. That was great. Does anyone else have any comments on that? That was a great perspective from Nepal in particular. I'm just curious if there's more general comments on that and looking beyond Nepal. Okay, well, maybe not. Oh, sorry, go ahead. Please go ahead.
I will add one more point. Actually, in terms of cost, as details of the cost are shown by Shwetaji, it may look like a relatively higher cost, but if we count the longer run, then in the longer run, the initial investment may be high, but in the longer run, it reduces the annual repair and maintenance requirements of the existing furniture system. That's why in the longer run, the cost seems to be not very high. The second point is through the continuous development, modification, adaptation, so we might be able to reduce the cost also. I think in terms of cost, I'll add that much.
Thank you very much, Sir. That's a really good point. And I wonder if our colleague in Bhutan, Yi Shilote, can comment on that and actually at the same time maybe answer a question that was posed. And the question was, has this design been adopted in Bhutan? I haven't seen or come across one to my knowledge. So Yishi, if you could respond to that, that'd be great.
Sure. Thank you. I think that was a good question. I think we started from Bhutan, as many of the presenters mentioned during their presentation, and we started in 2015, which took long time, and with the first phase and second phase, and we could implement in the two schools, one in Samsi and one in Phinsuling under Chukha Dzongkhag. And in case of the maintenance, I think that was the cost always it raised. So as Surya also mentioned about the long-term maintenance costs, and I've visited some of the schools, especially in the Phinsuling, and I could see only even after 10 years back, the maintenance is zero. It's very minimum, and I think that's very impressive compared to the ordinary decks that we used to have in the schools. So that's why I think in case of the cost and strategy wise, I think even in Bhutan, I think with
Looks like we've kind of lost Ishi. Sorry, Ishi.
Even in Bhutan, I think, can you hear me now?
Oh, yes, please continue.
Yeah, I mean, like with the tastings and a lot of things has through the Nepal project. So I think we could also implement that for the primary schools and also that can be implemented in Bhutan's projects. We'll do that. Thank you.
Thank you very much, Ishi, for that perspective from Bhutan. We have several questions that they pertain to aspects on safe behavior. And I think, Surya, if you could comment, there's kind of several that touch upon that. If you could comment on that, that would be great.
Thank you, Veronica. There are several questions related to this, related to drop, cover, and hold. Even for our poor masonry buildings, whether this drop, cover, and hold behavior is safe or not, and what you suggest to do a behavior during an earthquake. And I showed just one slide related to a study that we did in terms of death and understanding death and injury after the 2015 earthquake. And with that study also, we understood that even during that 2015 earthquake, even in masonry buildings, those who were running away got more injured than those who took shelter underneath the strong furnitures. And those who took shelter or who stayed safely underneath the strong furnitures. That was the finding that we could see. Therefore, even for poor masonry houses and even or for strong concrete houses, we still see that drop, cover, and hold is a safe behavior. But it is situational also. If somebody is just near to the exit, probably to exit from the building is the safe behavior. But in most of the cases, if people are inside the house or in the upper stories, in such cases, it is very difficult to exit the building immediately. That is why still it seems that drop, cover, and hold is the safe behavior and protection of this head injury and injury at the sensitive parts of the body is extremely important, and that's where the role of this earthquake desk comes. Thank you.
Wonderful. Thank you for addressing that. There were so many questions on that, so that's great. I'll ask one more question and then we're going to have to close because we're at time. But I'll have this question from, let's see. No, I lost the question. Okay, there we go. For Ido Bruno. So could the earthquake desk model be adapted for other disaster-prone countries?
Okay, so first of all, we've had some activities in other countries. Actually, with GHI, we began a beautiful project in Haiti, but unfortunately, due to political unrest in Haiti, we had to freeze that for a while, and I hope we get back to that. Actually, the idea there was quite nice to work with vocational schools and actually build desks with students who study welding and construction work. We have had some desks manufactured in Italy. There was a batch manufactured and sent to Taiwan. So the desk does exist in some other places as well, but due to a lot of different constraints, it has not spread as we would have imagined or wished it to spread, but it's an ongoing project. So the answer is yes. And also there are other similar product. There were a few questions about that. Similar products that more for office or for home use rather than schools that are also in the drawer and waiting.
Wonderful. Well, thank you so much for that. All right. So I think there's been several questions answered in written format, but we have a couple open ones. So I'll start with the first one we have here. It says the cost of these desks are very high during earthquake in Nepal 2015. The desks and bench and roll made of saw wood, Sharea robusta, were almost unharmed and used again and could work for efficiently than these desks. I was wondering if Surya could comment on this, given his experience in the 2015 earthquake and with the earthquake deaths as well.
Thank you, Veronica. I think, yes, at this moment, the cost of this earthquake desk seems to be high. But as we talked during the presentation also, in the long run, if we consider the annual repair maintenance cost of normally built desks and benches in Nepal in common practice, if we compare that, then this cost of this earthquake desk becomes still cost effective. That's one aspect. The second is, yes, we also observed in some locations these strong wood species like salwood. The desks and benches constructed, manufacture of that type of wood were very good. They were relatively in better shape. However, in rural areas, even now, the cost of these strong species of salwood has become extremely high. The cost of the wood is also extremely high. And the second point is ensuring the quality of construction of these desk benches, and also the possibility of variations in the manufacturing by wood is also very uncertain. And the third point is, nowadays, considering the cost of the wood nowadays, this desk benches made of common steel is also very much prevalent, and the quality control issues is still there. That's why I believe this quality controlled manufacture of this earthquake desk would be a very cost effective alternate solution to protect our lives. The last point I have is we observed during the 2015 earthquake, fortunately, the earthquake didn't happen in the school hours. That's why we don't have the school casualty data in the school itself. But we have casualty of students and teachers in homes, but not in the schools. But even then, we see that the basic killer during the earthquake was head injury, chest injury, and by the falling objects, falling debris. And if we can prevent that, then the casualty can be significantly reduced. That's the observation that we have from the 2015 earthquake. Back to Veronica. Thank you.
Thank you so much. Thank you so much for that very thorough answer. That was great. So the next question is I'll pose it to Ido. And the question is, can this innovative and life-saving solution be applied in any seismic zone or country?
Yeah, so generally speaking, of course, the answer is yes, but the desk is best utilized when the buildings are vulnerable. So if you have a country sitting on a seismic hazardous zone and the buildings are not up to standard or are not strong enough to withstand the earthquakes, then the desk becomes a very good interim solution until retrofitting or rebuilding of the buildings can be done, and that's relevant to any country in the world. We have these issues, and we know we have issues like that in Italy, in Israel, in Haiti, and in the different countries that are along the Himalayan range, etc. So the answer is definitely yes, but it needs to be checked in relation to the building.
Great. Thank you so much. It looks like the team did a phenomenal job of answering all the questions in written format. I'm wondering if there's any question that any of the people who responded wanted to comment on or add any verbal notes.
I would just like to say thank you for the engagement of the questions. I think, people are thinking really useful thoughts on how is this going to work and how best to make use of it. And it's really exciting to see people, really thinking it through. It's very good. Appreciate your interest.
Yes, and I'll just note, I think there was a question about their education program matching with this. I think that's one of the challenges, but also for me, one of the most exciting parts of this is bringing all these different aspects together, right? You can have a really wonderful technical solution, but the adoption is always a huge challenge. So bringing in the social, political, educational aspects are so critical and important. I'm wondering if anybody else wants to comment on that, perhaps Surya, I think of the importance of all your experience in this in terms of making sure that there's adoption when you have a technical solution.
The technical solution needs to be combined with a lot of advocacy and education, because the schools need to believe that these earthquake desks really protect. So that's why we need to work with the schools, the school authorities, local government, provincial and federal government also for the replication of these desks, and also for developing appropriate policies which will encourage schools to have these earthquake desks. So that's why this has to go hand in hand with awareness and education and advocacy.
Thank you very much, Surya. And yeah, just to stress again that really we're aiming for the long game here, not just going in and placing desks and being done saying, okay, we made one, some children safer, but putting in, thinking about the mechanisms, the processes, the protocols for being able to procure these desks into the future. And so really trying to understand those. And that slide of all the team members that I showed, there's so many different angles and perspectives that are so valuable to making that a reality. So with that, I think
one more comment, Veronica.
Sure, please.
We don't realize, but there is significant investment on desks and benches every year by the government and by private sector also. A significant amount of investment is being done annually, and if part of that can be saved in the long run by these desks, that will already be a big achievement actually, and with that saving, not just saving in terms of money, but that saves lives also.
Wonderful. Yes, thank you for adding that. And I think someone, just to read the last comment, I think the cost of manufacturing this desk can be reduced easily, significantly, but will children go under the desk or run in open space? I think that further stresses the importance of education, the belief that people say, I feel safe, I know this is the safest place. And so that's a really, really important part, because that behavior is really important to use it properly, right? And to have that confidence that it's going to protect you. We had over 60 questions come in. Thank you so much. It's wonderful to see all the interest, all the suggestions, the thoughts, and really helpful. We will be sharing a recording of this presentation, and I encourage all of you to please sign up for our newsletter so we can stay in touch. Thank you, everyone. Thank you to the speakers for their wonderful presentations, and thank you to everyone for joining. Have a good day, good evening. Thank you.
Thank you.
Thank you.